In this video, we're going to go through how to solve square root and cube root functions. So let's begin here with the square root of x plus 5 equals 13. So we want to isolate that square root of x. So we're going to subtract 5 from both sides, which gives us the square root of x equals 8. Well, we need to get rid of that square root. So it's a square root, so the inverse of square rooting is squaring. So we're going to square both sides, and that is going to give us that x equals 64. And that's going to be our solution. Let's try another one. So we have 3 minus the square root of x equals 0. Same idea. We want to get this square root of x by itself. So we're going to begin by moving that 3. So we're going to subtract 3 from both sides. Then that leaves us with the negative square root of x equals negative 3. We need to get rid of that negative sign. So now we're going to divide both sides by a negative 1, which gives us the square root of x equals 3. But again, we need to get rid of the square root now because we want just the x ultimately as our goal. So we're going to square not just the right side, but the left side. You have to square both sides. And that's going to give us the x equals 9. And that's going to be the solution. So basically, there are 3 steps for how to solve a radical equation. First, you get the square root by itself. Now, if it's cube root, you'll get the cube root by itself. Second, you square or cube both sides, depending on what type you're working with. And then third, you simply solve for x. Let's try a few more examples that are a little bit more challenging. So in this next example, we have 4 times the square root of x plus 2 plus 3 equals 19. So we're going to begin by subtracting the 3 from both sides. That's going to give us 4 times the square root of x plus 2 equals 16. Well, the square root's still not by itself, so we're going to get rid of that 4. So we're going to divide both sides by 4. So now we have the square root of x plus 2 equals 4. So now that the square root is by itself, now we're able to square both sides, leaving us with x plus 2 equals 16. Now we finish solving for x. So we're going to subtract 2 from both sides, giving us x equals 14 as our final solution. In this next example, we have the square root of 3w minus 9 plus 6 equals 15. Here, we're going to subtract 6 from both sides, which will give us the square root of 3w minus 9 equals 9. Because the square root is by itself, we're able to square both sides, which is going to give us 3w minus 9 equals 81. Now we want to solve for w. So we're going to add 9 to both sides, which gives us 3w equals 90. Then divide both sides by 3, giving us our final answer that w equals 30. And we're finished. So what happens when you have a square root equal to a square root? We're going to work on some of these as well. So when we have a square root equal to a square root, the first thing you want to do is square both sides because it eliminates the roots, leaving you with simply 2x minus 1 equals x plus 4. So there, we'll go ahead and subtract that x over, leaving us with x minus 1 equals 4. We'll add the 1 over, giving us a value of x equals 5 as our final solution. You try letter B on your own, so go ahead and push pause, and when you're done, push play, and let's see if you were right. So you should begin with squaring both sides to eliminate your square roots, which leaves you with 3x plus 1 equals 4x minus 7. From here, we'll take the smaller x value and move it over to the bigger x value. So that's going to leave us with 1 equals x minus 7. From here, we'll add our 7 to both sides, and that will leave us with x equals 8. And that's our final answer. Now I know what you're thinking. You said we were going to do square roots and cube roots. So let's go ahead and let's do some cube root examples. So here we have the cube root of 5x minus 2 equals 12. So in this situation, our cube root is already by itself. So we can skip straight to the cubing both sides. Why do we cube both sides? Well, because the cube root. And a cube and a cube root are inverses of each other, so that eliminates those pieces, leaving us with just 5x minus 2 equals 12 to the third power, which happens to be 1,728. So from here, we're just solving an equation. So we're going to add 2 to both sides, which gives us 5x equals 1,730. Divide both sides by 5, which gives us x equals 346 as a final answer. So let's have you try letter B on your own. So go ahead and push pause, work out the problem, and then push play, and let's see if you were right. So here, our cube root's already by itself, so we're going to cube both sides because it allows us to cancel out our root, which gives us 3c plus 7 equals 1,000. So from here, we're simply going to solve. So we're going to subtract 7 from both sides, and that's going to give us 3c equals 993. From here, we'll divide both sides by 3 to be able to get our c by itself. And so when we divide 993 by 3, we get 331, and that's our final answer. Now, a word of caution. Sometimes you'll have extraneous solutions, which means that you work it out, but when you plug it back in, it doesn't work. So maybe let's talk about one or two of those as well. So here we're going to be solving and checking for extraneous solutions. So here we have x equals the square root of x plus 6. So we already have the root by itself on the right-hand side, so we're going to go ahead and square both sides to get rid of that root. So now we have x squared equals x plus 6. So we want to move the x plus 6 over to the side with the x squared, so we're going to subtract x and 6 from both sides, which gives us x squared minus x minus 6 equals 0. Well, we need to factor our x squared minus x minus 6. So two numbers that will multiply to negative 6 and add to negative 1. 1 and 6 don't work, but 2 and negative 3 will work. So we can factor this to x plus 2 and x minus 3 equals 0. Using the zero product property, we can now say x plus 2 equals 0 and x minus 3 equals 0. Solving for x on the left, so we'll subtract 2 from both sides, we get x equals negative 2. And then on the right-hand side, we'll add 3 to both sides and get x equals 3. But now we need to check to make sure that they work. So let's plug in our negative 2. So we plugged into the original equation. We're going to plug this portion into our calculator, and that's going to give us a value of positive 2. But when we check, positive 2 does not equal negative 2. It's not the same thing. It doesn't work. So this is going to be an extraneous solution, so like an extra answer. So let's check our 3. So we're going to plug 3 in. We plug in our right-hand side into the calculator, and that gives us a value of 3. We check it. That does work. So x equals 3 is a solution. So let's have you try letter B on your own. So go ahead and push pause, and when you're done, push play, and let's see if you were right. So we're going to begin by getting the square root on the by itself. So we're going to subtract 13 from both sides, leaving us with the square root of 5n equals negative 10. Now we'll square both sides, giving us 5n equals 100. We'll divide both sides by 5 and get n equals 20. So now we want to plug that 20 in and make sure that that works. So let's plug that in right here. So 13 plus the square root of 5 times our 20, and we want to know, does that equal 3? So this time we're going to be plugging this side into our calculator, and when we do that, we get a 23. So when we compare that, we see that it does not work. So this is going to be an extraneous solution. And so in this situation where we don't have any other answers, that means that the answer we're going to have is going to be no solution when that happens. And we're finished. And so that's how you can solve square roots and cube roots. Just make sure that you solve and check for extraneous solutions.